JSS1, welcome to this YouTube video. Welcome to today's class. Welcome back to school. How have you been? I hope your week has been going on well. I hope your classes, you've been enjoying all your classes so far. In other subjects, I hope you've been focusing. I hope you've been learning as much as you can. Okay? So, I would like to say to you guys, welcome to today's math class. For some time now, for the past 2 or 3 classes or 4 classes, we've been talking about plane shapes, right? You remember we've been talking about plane shapes, and then we talked about the perimeter of plane shapes. Then we went into area of plane shapes, right? Okay, so today's math class. Okay, before we begin the class, I would like us to say thank you to the proprietor and proprietress and to all the teachers who have been teaching you. We say thank you to the proprietor and proprietress for making this platform available for us to teach all of you. We say thank you to them, and then we say thank you to the teachers as well who have been teaching you all of your subjects, and then say thank you to them. You should appreciate them for this that they are doing. Okay, so moving on, where we've been, like I said, we've been talking about plane shapes from the beginning, right? And then we've talked about perimeter of plane shapes, and now we are on area of plane shapes. And last week we started with an introduction, and then we moved into the area of plane shapes, actually irregular and regular plane shapes like rectangles, squares, parallelogram, trapeziums, and triangles. Okay, so today, and then I think earlier this week we talked about trapezium and triangles, and I told you that today we're going to be looking into circles and composite plane shapes, right? Circles and composite plane shapes. So let me just quickly do a revision of what we've done so far. Remember I said a plane shape is the amount of space that a shape covers, right? The area of any plane shape, the area of any plane shape is the space that plane shape covers. Okay, so that's what the area of the plane shape means. And then I remember at the beginning I also told you about the unit of measurement of area is square unit, being square units. Okay, whichever whichever method of measurement of length which you are using, whether centimeters, millimeters, meters, kilometers, and what have you, you always have a square. All right, if it is centimeters, centimeter square, that will be the area. If it is millimeters, it will be millimeter square. It will be, if it is meters, it will be meters squared. All right, it will be meter square. And then I remember showing you the standard unit for measuring various sizes, right? So measuring the area covered by any area, basically at a basic level. You see, now at a very, very small level, we can use a centimeter square, right, to do the measurement of it. All right, and then for larger areas like your playing field, your classroom, your gardens, your classroom floor, your garden, and so on, you can use your meters to measure it. And I think I remember I explained that to you in the last class. The reason why it is that way, you can't be using centimeters to measure a larger area. You just make use of meters. All right, the meter rule to do that. And then for even larger area like farmlands, your school compound, plantations, a state, or even a whole country, you need to measure using square kilometers, or hectares. As you can see, those are the 3 ways. So basically, they are also, remember, explaining to you unit conversions. I believe you all remember these ones. All right, and then some of the areas we've done so far. Below are some of the areas of plane shapes which we've learned so far. I believe you all remember all the area of plane shapes which you've learned so far. We've learned the area of a rectangle. Area of a rectangle is length times breadth. Do you all remember that? Always remember. And then the area of a square is length times length. right? Which could also be interpreted as length squared, right? Because all the sides of a square are equal. And then area of a parallelogram is defined as the base times the height. Can you see that now? Let me take my pen. Let me pick my pen to highlight for you. So you see area of a square, you see area of a parallelogram. Do you see that now? Which is base times height, which is also, we can also be said as BH, right? Then the area of a triangle, and I believe last week I showed you how we coined out the area of a triangle from the area of a parallelogram. Do you see that now? If you don't remember, go to your previous notes and then study it, okay? You find it there. And then that's the area of a triangle, which is half times base times height, okay? And then the area of a trapezium is what we have as half times a plus b times the height, okay? That's the, for the trapezium, you know the shape of the trapezium. You know, trapezium looks something like this. Looks something like this. So this is your A, this is your B, right? And this is your height, right? So 1 over 2 times the A plus B times the height is what we found um, our area of the trapezium to be. All right, and those were the things we've covered so far. So today we want to look at area of circle, area of circles. All right, area of plane shapes, and one of the shape we're looking at for today is circle. And then after that, we'll also be looking at composite shape and plane shapes. All right. So now let's look at this. Let's do a little practice of something. I want you to take your protractor and your pencil. All right, take your protractor and your pencil. Um, Set the pencil to be at equal length with the edge of the pin of the protractor. Make sure they are both on the same position. All right, they are the level. There is no extension of any of them. All right, and then you can just make use of any radius you want. You can use it to measure. You can measure 1 centimeter or 2 centimeters or 3 centimeters, whichever radius you choose. Okay, and then draw a circle of any radius of your choice on a chalkboard, on a cardboard paper rather. Okay, and then now what you do is you divide the circle into 12 sectors of 30 degrees each. So like you can see as I've done in this diagram, do you see that now? You do slash 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 slash, all 12 equal sides, equal sectors rather, they must be equal, okay, of 30 degrees each. And when you add everything together, you have 360. 12 times 30 is 360. Okay, so then we are not done with the practice. Look at what we'll do next. Now you would cut each of those sectors, you cut them out, okay, cut them out and arrange them in a way that each radius touches the radius of the next sector, as you can see in the figure below. In this image here, as you can see that it is done. Okay, when you do that, then it says a plane shape is formed, and that plane shape, if you look at this actually looks like a parallelogram. Do you see that now? Something like this, something like this. You know the way a parallelogram looks now, right? Do you see that now? So now the opposite sides are half of the circumference of a circle, which means pi r. Now what does that mean? What you see here, this side and this side, they are the opposite sides of the parallelogram, right? And they are what? If you look at from the circle, you cut from the circle. You see this side is half of a particular circle, this side is half of another particular of that same circle. Do you see it now? How do we know that it is half? You divided the circle into 12 places, right? Good. So let's count. We have 1, 2, 3, 4, 5, 6. Do you see that now? 6 out of 12 is half of 12, and then you have the remaining 1, 2, 3, 4, 5, 6. You see that now? You see that both sides are what? They are both those opposite sides, they are semicircles. All right, they are half of the circle, while the height of the shape, as you can see here, the height of that shape is from the radius. Do you see that now? Of the circle. Okay, so then we move on. The half part is the base of the parallelogram. That is, you see, this or this is the base. And according as we know that the area of a parallelogram is what? The base times the height. What is our base? The half of the circle, which is pi r. Do you see that now? And then what is our height, which is our radius? Do you see that now? So our base is this, and this is our height, all right, for the parallelogram. And then when we multiply that, pi r times r will give us pi r square. So that is the area of a circle, okay? Therefore, the area of any circle with a radius r is always given as a, as that is area, to be equal to pi r square. The area of circle is always what? Pi r square. And then there are some important things you need to know about pi. That statement, that word pi that we use all the time, that pi is represented as 22/7 or 30 or 3.142. Okay, so let's take a look at some examples basically. Now take a look at this example. It says, find the area of the circle shown below. Now the circle has a radius of 3.5 centimeters, right? Okay, so what is the area? Formula for area of a circle? Formula for area of a circle is pi r squared, right? And your pi can be 22/7 or 3.142. So in this example, I chose to make use of 3.142. Okay, you can make use of 22/7 and you still get the same answer, all right? So our pi, 3.142 times our radius is 3.5 centimeters, right? Squared. So when you square any number, that means you multiply it by itself again, all right? So that is 3.142, which is pi, times r squared, which is 3.5 times 3.5. Do you see that now? And all, because we are talking about area, all will be centimeters squared, as you can see here, right? So the final answer, when you are done multiplying, maybe you use your calculator or you make use of something else, you get 38.49 approximately. Actually, that's correct to 2 decimal places. Okay, that's correct to do 2 decimal places. Actually, what you get is 3.4895. Yeah, that's what you get. So approximately we have 38.49 centimeters squared. All right, so that's that about that. Let's look at another example. Look at this example. It's a word problem. I would like you to take note of it carefully, right? So now it says the circumference of a circle is 72 centimeters, right? Now we are looking for we are talking about area, but what we have here is the circumference of the circle, right? It now says calculate its area and correct the 2 decimal place, right? Now, good. Now, we know that the formula for circumference of a circle from the beginning, when we were talking about perimeter, remember I told you that the circumference of a circle or the perimeter of a circle is 2 pi r. Do you see that now? As we have done in the beginning. So now, so we now represent the circumference of the circle, which we've been given to be 72, right? Will be equal to 2 times pi times r, right? And our pi, I used 3.142 in this one as well, times our radius. We don't know the radius yet. Is that not so? We don't know the radius yet. So, because we need to find the radius to be able to calculate the area of the circle, okay? So, 2 times 3.142, you have 6.284, okay? So making r the subject of the formula, you divide by 6.284, okay? So that will be 72 divided by 6.284 centimeters. And then the answer you get is what? 11.45 centimeters. So that's our radius. Our radius is 11.45 centimeters, correct to 2 decimal place, okay? That's making sure it is in 2 decimal place. Now, what's it called now? Then since we now know our radius, then we can find the area of the circle. Is that not so? So we have um, the area of a circle is pi r squared, right? Area of a circle is pi r squared. So what is our pi? 3.142, like I've been using, times r squared, which is 11.45 squared. And then when you expand that, that gives us 11.45 times 11.45, right? You see that now? And then squared, centimeter squared. And then the area of the circle, when you multiply all of that together, you have 412.36 centimeters squared. All right. So moving on to composite plane shapes. Now that's all about the circle. That is all we can do about circle in today's work. So I would like you to continue to study on your own and learn more about working with the area of a circle. All right, now look at the composite plane shape now. It says when two or more plane shapes form another shape, the new shape is called a composite shape. Do you get it down? And it's when more than one shape come together, more than one plane shape, when they come together to form a new shape, that new shape is called a composite plane shape. And you can see the figures below, A, B, and C. They are examples of plane shapes. Look at this now. A is a combination of two rectangles. B is a combination of a very large rectangle and a small rectangle, right? And then C can be a rectangle here, and then maybe another rectangle here. This one is a rectangle and another rectangle. This one is one rectangle and a large rectangle. Do you see that now? So we'll look at the examples. Now look at this example. Now find the area of the shape below. Now you can see that this is a rectangle, this is another rectangle, and this is another rectangle in the middle, right? So to make it clear, then you say you have to divide the shape. Actually, the shape can be divided into three rectangles. Do you see it now? And that's so we then add the area of these three examples together, of these three rectangles rather, together to form the total area of this composite shape. As you can see, the area of the first rectangle of length 15 centimeters and breadth 3 centimeters. When you do that, you have 45 centimeters square. The second rectangle is this one, which you have length of 4 centimeters and breadth of 3 centimeters. You see that now? And then the last rectangle, this one, is also the same length with this one. So 15 times 3, 45. So when you see that the total area of the shape will be the first area plus the second area plus third area. And that is how we have 102 centimeters. All right. So moving on to the second one, I think we also have three rectangles in this one as well. We have a rectangle here, we have another rectangle here, we have another rectangle in the middle. You can choose to divide it in any way that you like, in any way of your choice. All right. You can see that the rectangles are labeled in both of them. This is rectangle 1, this is rectangle 2, and this is rectangle 3, as you can see in the labeling. The same thing here, like rectangle 1, rectangle 2, and rectangle 3. You get it now? So look at this now. There are three rectangles. The one with length of 13 millimeters and the breadth of 7 millimeters. All right. And then this one, the next one is this one of breadth of 4 millimeters and length of 9 millimeters, right? And then the third one is this one, length of 9 millimeters and breadth of 5 millimeters. Okay, so their areas are what we calculated here, and then when you add all the three areas, you have what? 172 millimeters squared. That is the area of the total shape you can see there. So you add all the area of the division of shapes, all right, together, and then you get the total area of that shape. All right, look at this one now. This one is also another one. It says calculate the area of the doorway drawn in the figure below. Now this is a doorway that you can see here. Now in the solution, you see that the doorway is made of two shapes, right? So we first divide it into those two shapes. The two shapes are what? A semicircle, this one that comes like this, right? And then a rectangle, this one that comes like this. Do you see that now? So when you put this one on top of this one, you have your complete doorway. All right. So the solution now, we divide both of them and then we find the area of the two of them first before we add them together, as we've been doing from the beginning for composite shapes. Do you see that now? For composite plane shapes, you first separate all the shapes that can be formed from it, then you find their different areas and then you add them all together. All right. So the area of a semicircle is half of, a semicircle is half of a circle. So whatever the area of a circle is, it will be half of that. All right. So the area of this semicircle is half pi r squared, right? And what is our radius? Now you can see that what we have here is 49. The length from this side to this side is 49 centimeters, right? But that means that is the diameter, right? That is the diameter. The diameter is the total, is the length from one side of the circle to another side of the circle, passing through the center of the circle, right? So half of a diameter is what? A radius. All right. So the radius which we have here will now be half of the diameter, which is 49 over 2. All right. So 49 over 2 times 49 over 2, that will be our r square. Okay. And then in this one, I'm also using my pi to be 3.142, as you can see here. Okay. So when we multiply and cancel and divide and cancel everywhere, all we have left is when we do our half times 3.142 times 49 times 49, we have 3,773 divided by 2 times 2, which we have here. 2 times 2, sorry, this 2 times this 2. All right, to get our 4, which we see here. So when we divide that, we have 943.25 centimeters squared. That's the area of the semicircle. All right. And then now for the area of the rectangle, length times breadth as usual, Abby. And then 90, the length 90, and then the breadth 49. When you multiply that, you have 4,410 centimeters squared. So the total area of the doorway will now be the area of the semicircle plus the area of the rectangle. And what do we have? We have 5,353.25 centimeters squared. I believe this is a simple explanation for you. And I have exercises for you as well. I hope the class was an understandable one for you. So your exercise is going to be in your new concept mathematics textbook for your class JSS 1, page 218, and you do exercise 16.7. Exercise 16.7, you just pick questions 1, 2, and 3. All right, and then you do that for me. Okay, so at this point I would like to say thank you all for watching the video. Thank you for following it to the end. I hope you learned something in today's class. Once again, I say welcome back to school. God bless you. Take care of yourself. Enjoy the rest of your weekend, and see you in our next class. Goodbye for now.